Okay. So today we look at chemistry and we look at a very important topic in chemistry. We
Okay.
look at we look at chemical bonding, what bonding is all about, how the different substances interact, different element compound and what have you, molecules interact. Okay, before you understand this topic, Alicia, you know about your electronic configuration, right?
Yes.
You know about your electronic configuration. So um, chemical reaction takes place as a result of instability. You can say that the atoms, elements, atoms, and what have you, they are not what? They are not, atoms basically is neutral, yes. But when there is a kind of imbalance as a result of as a result of call it ionization or what have you, there's always a tendency to complete that octet or duplet structure by
Okay.
electron either being exchanged, being transferred, or electrons being shared between two or more entities. Now, based on what I just said now, we will look at what a compound is. What a compound is, you know, a compound is formed as a result of a chemical reaction, and
Yeah.
the compounds, what is formed after a chemical reaction is always entirely different from the reactant that came together to form that particular compound. For example, now something like sodium and chlorine. Sodium and chlorine coming together to form sodium chloride
Fluoride.
is one it is one mystery. Of course, before that can happen now, ionization will take place in the presence of what is it called? In presence of moisture, you see sodium ionizing, chlorine will ionize, then they would have exchange of electrons. And transfer of what? Electron from
Okay.
sodium. Sodium will lose its electron, then chlorine will do what? Accept it. You know that the chlorine that is accepting it is not chlorine gas now. It's the
Yeah.
chloride ion that is
Yeah.
accepting that. So that's why I say before now that before they can bond, the ionization will take place first before they can bond. Now, sodium is one kind element that on its own, by combining with water alone is a serious, dangerous reaction, violent reaction. Chlorine on its own is poisonous, but when these two come together, they form sodium chloride, which is the salt we use every day. So, what does this tell us? That chemical compounds are always different from the, unlike mixture that has all you need to do is just there's no reaction. Two things that came together, bring sand, bring sugar, put it together. Sand is still there looking at you. The sugar is still there looking at you. No bonding between the two of them. Now, but when a chemical compound is formed, it's not like that. So this is a way of what? Introduction. Now, for us to now appreciate what I just said now, we look at so with this thing I said now, if you ask now what is chemical bonding, what are you going to say? What? If you ask now what is chemical bonding, what are you going to say from these things that I've said in the past 10 minutes?
I would say that chemical bonding is simply the coming together of two elements to form a compound.
It's not enough. What happened? There's something happened. There is something that happened between the two of them before they can form a compound. Either by
In a fixed proportion of mass,
is that what?
they combine in a fixed proportion of mass to form the compound.
Okay, okay. But what makes it a chemical reaction is that there must be electron movements.
Okay.
There must be electron movement. If there's no electron movement, there is no bonding. There is no compound will be formed. There must be electron movement. The movement can be transferred from one to the other. One must lose, another one must gain, or two of them will share. That is what bonding is all about. Is that clear? Now, the main types of bonding. We can call this bonding or combination, chemical combination, because it's all about combining, two elements to form
a compound.
a compound. So now it may not necessarily be element two. Hope you know. Two compounds can still come together to form another compound. Hope you know.
Yes.
So it may not necessarily be. It may not necessarily be. In fact, two elements can come together to form a compound. Two compounds can come together to form another compounds. Then an element and a compound can come together to form a compound. Are you aware?
Yes, yes.
Sodium is an element. Water is a compound. They can come together to form another compound. So now we have the main types of chemical bonding combination. We have the electrovalence or the ionic combination bonding. Then we have the covalent bonding. Now, electrovalent bonding is the one that has to do with what? Transfer of electron. Electron will move from one will lose electron. The electropositive one will lose electron. And the electronegative one will do what? Am I communicating? Will accept the what? Electron. The two of them will form stable octet structure in the compound. That's what happened. Now we have covalent bonding. This one, covalent bonding, requires sharing of electrons. Sharing of what? Electrons. Now, the covalent bonding is subdivided into two. We have the ordinary covalent bonding and the coordinate or dative covalent bonding combination. Ordinary one is all about, remember, covalent is about sharing. In ordinary covalent bond, the two atoms involved, two of them contribute electron and share. But in dative or coordinate covalent bonding, only one will donate low pair of electron, the other one will share it with it. The other one is not donating anything. Does it make sense?
Come again, that dative covalent bonding.
I said that dative covalent in dative covalent bonding,
Yeah.
only one of the atoms bring a pair of electron or whatever number of pairs for the two atoms to share.
Okay.
One atom does not contribute anything. It's only to come and share. Is that clear?
Yes.
Good. So that's what happened in dative covalent bonding. So now let's look at a electrovalent bond. Let's look at a electrovalent bond. I've talked about what it is. So let's just give example. During the formation of sodium chloride between sodium and what? Sodium atom and what? Chlorine atom. What happened? Let me set the board.
Okay.
Can you see the board?
Yes.
Huh?
Yes.
Clearly.
Yes.
Good. So I'm going to talk about what happens in what?
Electrovalent bonding.
So the topic is chemistry. Now we want to look at what happened between sodium and what?
Chlorine.
Chlorine atom. This is atom. This is what? Atom. Now, remember your electronic configuration. Remember,
Yes.
because of want of space, I don't want to start using the one by shell by drawing the shell, circle. So let me just use number to represent each of the shells. Is that clear? Well, what is the atomic number of sodium? Huh?
What?
Do you know?
What?
Do you know the atomic number of sodium?
I think it is 11.
11. Thank you. Hope the board is clear.
Yes.
So atomic number of sodium is what?
11.
It's 11. Good. What of chlorine? Chlorine is what?
I think it's 17.
Good. 17. And what? 17. Now look up. See what happens here. For sodium, if you start, you know that the innermost shell, the maximum there is what? 2, right?
Yes.
The next shell, the maximum there is what? 8,
8.
right?
Yes.
The next shell, the outermost shell, 2 plus 8 is 10. So we have 1 remaining. So the outermost shell
Yes.
is what?
1.
1. This is just the shell. I'm not going into orbitals,
Yes.
just the
Yes.
shell. Then this is what? For sodium. For chlorine, let's do again. The innermost shell is what? 2.
2.
The next shell is what? 8.
8.
The next shell is what?
7.
2 plus 8 is 10. 17 minus 10 is 7. So the outermost shell is what?
7.
7. Now, this is sodium, this is chlorine. As atom, the
Yes.
electron in the outermost shell of sodium is 1. The electron in the outermost shell of chlorine is what? 7. Right?
7. Yes.
Good. If these two want to go into chemical bonding, it's easier for this sodium to let go of the what? The 1
The 1.
in the outermost shell.
Yes.
But it's difficult for this one to lose the 7 electron because there is a strong, in fact, there is a strong what? Attraction between the positive central nucleus and that electron outside. Even though we have shielding, but having up to 7, do you know what it takes to start losing? It's not possible. So the only thing chlorine can do, I remember chlorine need to attain stable octet configuration. So the only thing chlorine can do to be able to do that easily is to accept 1 electron here. True or false?
True.
Accept 1 here to complete here to be 8. Don't be so.
Now so.
But here, the same thing with sodium. For sodium to maintain stable octet configuration, it can do it by losing 1 and maintain octet configuration of neon. But
Yes.
it can also gain 7 if possible. Gain 7. But is it possible for you to gain 7? Why instead of trying to? The best thing is to let go of this 1 remaining. So if that's why it can easily lose what? 1 electron. So this electron now will be transferred to where? Chlorine. Is that clear?
Yes.
And if the electron is transferred to chlorine, see how their configuration will now look like. Sodium will become 2, 8, stable octet configuration. Chlorine will now become 2, 8, 8. Of course, you know that.
Yes.
At this, you know that at this point now, this is no longer chlorine, it's chloride. Hope you know.
Yes.
It's chloride. It's what? Chloride.
Right.
So this is basically what happened. You can mute your mic. Just mute your mic. If just mute your mic to avoid interference. If I ask question, you can answer. Is that clear? Then okay. So this is exactly what happened. So if you now want to represent it to make, look at this now. Sodium is 1, 2, right? Here is electron. We have 1, 2, 3, 4. Then the outermost one is what? 1. Chlorine is 1, 2, 3. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 8. Then 1, 2, 1, 2, 1, 2. Then 1, 7. So sodium will now lose this one and it will get attached to this. And when this get attached to this now, they will form what? They will now form what? Ionic what? Or electrovalent bond. They will form what? Ionic or electrovalent bond. Does it make sense?
Yes.
Huh?
Yes.
It makes sense, right? Good,
Yes.
good. Now, there's something I want you to know.
Okay.
Remember what I said. This thing you are looking at, this thing you are looking at, they will say sodium chloride. They will say what? Sodium
Sodium
chloride.
chloride.
If you look deep into, if you look deep, very deep into it, it actually exists like this. This is how it actually exists.
Yes.
This and this this is how it actually exists. This sodium ion, the configuration is what? 2,8. Configuration of sodium ion is 2,8 too, because it has lost one what?
One
Electron.
electron.
This one is what? 2,8,8.
288.
Is that clear?
Yes.
This is not chlorine atom again. This one is chloride ion. This is not sodium atom again. It's now ion. This is how they exist. Is that clear?
Yes.
Is that clear? Good. Of
Yes.
course, you know that the this positive now means that the number of proton in this in sodium ion is more than the number of what? Electron, because the proton is at the center, it's not lost. It's electron that get lost. So that means, you know, that for an atom to be neutral, number of proton is equal to number of what? Electron.
Electron.
So when it loses one electron, instead of the atom becoming positive, neutral, everything will now turn to positive, because number of proton is more than number of what? Electron. And in
Electron.
that case, and in that case, what happens is that it becomes it becomes ion, move from atom to ion. The same thing here. Chlorine atom on its own has equal number of electron and proton. When chlorine gain electron from sodium and form this octet configuration, number of electron in the chlorine, the number of electron will be more than the number of what? Proton by one. And if that happens, it will have this negative charge. I don't know if this explanation makes sense.
Yes.
So this is basically what happened in what? In what? Electrovalent or what? Ionic bond. Of course, you know that ionization remember I told you that ionization will take place. Sodium will do what? Sodium will do what? With electron. We have what? Sodium ion. This means that the electron is lost. Is that clear? Good.
Yes.
Then the chlorine we gain the what? Electron and form what? Chloride ion. Is that clear? This means that
Yes.
you take electron, everything become more of negative than what? Positive. This one, electron goes, this becomes positive. So this is basically what happened. So based on this now, I wouldn't want us to waste time on it. I want you to see what I want you to do. I want you to write that of research, write that of or explain that of magnesium oxide. Is that clear?
What?
See what to do. See what to do as an assignment. the same thing I did. Describe what I did. Do it for bonding between magnesium and oxygen. Between what? Magnesium and what? Oxygen,
Magnesium
oxygen
and
atom.
oxygen.
Yeah, to form magnesium oxide. So you use the same pattern. So in the next class, you let me know. Is that clear? Is that clear?
Okay. Yes.
That is, if what I explained is clear, do that for magnesium oxide. Also do that for magnesium chloride. Good. I like that. I like this one. Do this for magnesium chloride too. At
Okay.
least it will explain why we have two here. So do it for that one too. These two. All right. So let's go to the next what is it called? Next type of what? Okay.
Type of
Before I do that, let's look at the properties, characteristics of what? Electrovalent what? Bond. Is that clear? Let's look at the
yes.
properties. In an electrovalent bond, there is electrostatic force of attraction, and this electrostatic force of attraction is very, very strong. Hope you know the reason. Between the positively
No.
charged and positively charged. Let me use sodium chloride as an example now. Positively charged and what? Negatively charged. There's a strong electrostatic attraction between this positive charge and this what? Negative charge. And that's why it's a very strong bond. Is that clear?
A strong electrostatic what?
Force
Okay.
of attraction between this positive charge and positive charge in sodium ion and negative charge in what? Chloride ion. So because of that strong electrostatic force of attraction, ionic bond is very strong. Is that clear?
Yes.
Good. So this is one of the properties. The other property I want to talk about, I have told you about it now. That it consists of ions, is not molecules. Is that clear? Consists of what? Ions, not molecules now. Not molecule is what? Ions.
Ion.
So you start talking about molecule when you go to covalent bond. Is that clear? Good.
Yeah.
Now, how do they exist? How do they exist? In fact, the structure of a compound formed as a result of ionic bonding. The structure is very, very organized. It's arranged in orderly manner. It's arranged. You see something like sodium chloride. You see them arranged like this: sodium chloride between sodium and what? Chlorine. You see them arranged like this. Let me say these are the one. The shaded one is maybe chlorine. The unshaded one sodium. Shaded one chlorine. Unshaded one sodium. Well organized. This one shaded, unshaded. Very, very organized. Shaded, unshaded. This is how they arrange themselves in lattice. Is that clear? The structure is arranged in orderly manner to form crystals. Please know that point. Crystals. They form what? Crystals. Is that clear? Good.
Yes.
Good. So now another thing I want you to note is that compounds formed from ionic bonding, they have high melting points. They have high melting point and high boiling points. Still, because of the what? The bond between what? The positively charged sodium and negatively charged what? Chloride what? Ion. So they have very high melting and boiling points. So sodium salt, this sodium Have you ever carried out evaporation of salty water, where you dissolve salt in water and put in an evaporating dish and heat it? The water will evaporate and go. What you left, what you see there in this is now the sodium chloride. Do you know the temperature at which this sodium chloride melts? It melts at temperature of about 801 degrees Celsius. 801 degrees Celsius. This one can melt you, John. No be so. No. This is very high. You can even touch sometimes at 100 degrees Celsius. You can't hold it now. No be so. It will burn your hand. Then let alone 801 or more sea temperature. Sea temperature. So it's very, very what? High. Is that clear? Very, very high. Of course, now when it now melts and start boiling, the boiling is almost 1,400 and something degrees Celsius. Now, another property I want us to look at is that compounds from ionic bond or electrovalent bond, they are soluble in polar solvents. They are soluble in what? Polar solvents. Example of popular polar solvent we know here is water. Why? Polar solvent is a solvent that has two partially negatively charged poles. Two partially opposite poles. One is partially positively charged. The other end is what? Partially what? Negatively charged. Now, remember this is like this, right? So because of this now, sodium chloride can easily interact with this. This positive charge with everything, the negative aspect of it will surround this what? This chloride ion. Is that clear? Why the negative charge? Remember, like poles attract. Unlike charges attract. Unlike charges repel each other. Right? Good.
Yes.
Now, because the polar solvent has two ends, two poles, this is partially positively charged. This one is partially negatively charged. And water is like this. You see water, hydrogen and oxygen, the other end. Water is like this. Now, because the water is like that, it can interact with sodium chloride. We call it solvation. We call it what? Solvation. So this positive end will interact. We do what? Interact with what? Surround the what? Let me use the actual listing. We surround the what? The chloride ion. While the negative charge will be attracted by the positive charge of sodium ion, and it will do what? And it will do what? Interact with the sodium ion is positively charged. So the negative end will interact with the what? Sodium ion. So the moment
I'm not seeing the board, though.
Is that what?
I'm not seeing the board.
Can I see it now?
Camera. Yes.
Good. Now, but what I explained, okay, let me do it again. I say that that sodium ion, compound from ionic bonding, they are soluble in polar solvent. And I said that a polar solvent is a solvent that has two ends, partially positive and partially negative ends. I gave examples. I used water. Is that clear?
Yes.
Now, why this is how polar solvent is. But this now is why does compound like sodium chloride form from ionic bond, interact with this and get dissolved? That's what I'm trying to do, what explain. How, why does it interact with this and get dissolved? I say that normally this sodium chloride exists like this. Now, like charge repel, unlike charge attract. Here is sodium positive. Negative end of this will surround what? Is that clear? This sodium.
Yeah.
Then here is positive. Surround what? Chloride, sorry. And because of this now, this process is what is called solvation. Because what's going on, they will interact, this will interact with this, this sodium chloride will do what? Dissolve. We do what? Dissolve. Without wasting time. Dissolve. So this is what I mean by the property that say that they are soluble in what? Polar solvents. They are soluble in what? Polar. Please mute your mic. Mute your mic. Mute your mic. Good. Now another property is that compound from ionic bonding, that they are good conductors of what? Electricity. They are good conductors of what? Electricity. Especially their electrolytes. Their electrolytes are good conductors of what? Electricity. Like now, in this solution form now, this can conduct what? Electricity, because of the ion flying up and down. Is that clear? Is that clear? Good. So they are good conductors of what? Because remember, these ions carry their charge. These ions now, this thing you see now, anyway, they can carry current from place to place. So in liquid, ions, they move freely when they are in liquid state or in solution. That's what I'm trying to do, what? Explain. Is that clear? Is that clear? Okay, yes. Now let's look at I've already told you that they exist in crystal form, right? I think I've said that, right? Yes. They exist in what? Crystal form. Huh?
Yeah.
Okay. So now let's go to this. Is all I can take here on what is it called? Covalent, ionic what? Bonding. Now our time has elapsed. I have another class by 5 p.m. So this class will end roughly maybe 5:55 p.m. so that I can attend to other classes. Is that clear?
Yes.
Now, no, I mean 4:55. Yes. Now, let me just say one or two things about covalent bonding. Covalent bond. Now, I told you before now. Nature, you're welcome. Don't mind me. You're welcome, Nature.
Thank you, sir.
How are you? Let's continue. So, my battery is low. What is going on? Hey, wahala. Okay. I said before now that covalent bonding, that what is it called? That covalent bonding has to do with sharing of electricity. It's not about transferring. No, it's sharing of what? Electron. Remember, this one has to do with molecules, not ions. Now, sharing of what? electron. And I said that we have two types of covalent bonding. We have the one we call ordinary covalent bonding. The one in ordinary covalent bonding, the two atoms involved bring electrons. They donate an electron and share between the two of them. While in let me use simplest something now to simplify this thing to talk about explain this. Let me just use how oxygen, some of these diatomic molecules are formed. You see oxygen, or let me do the simplest one, hydrogen. Hydrogen, right?
Yes.
Hydrogen. And hydrogen is what? How many electrons does it have? Hydrogen atom. One, right?
Yes.
Plus another hydrogen atom. One, right?
One. Yes.
They will come together. What happened? Their target is to form hydrogen gas, right?
Yes.
So this is what they will happen. Two of them will come together and bring these two electrons and do what? Share it. Is that clear?
Yeah.
They will share the electron. This is the bond between them. So this is what we have as hydrogen what? Hydrogen what?
Gas.
Gas, diatomic what? This is now a molecule. So there's no loss of electron or whatever. They donate and share. Then there's also there's also a situation whereby even chlorine behave like that too. Chlorine, chlorine as a molecule, it exists like this, right? Remember, as a molecule, it exists like this. So the two atoms of chlorine come together to form chlorine what? Molecule.
Molecule.
So a chlorine molecule has two atoms of what? Chlorine. Is that clear? Okay, now let me no, there are different ways you can represent it. You can also represent this using Lewis.
Okay. Can you hear me?
Yes.
I just used to start a lot early.
What?
So I joined it.
Hello? Can you hear me?
Hello.
Okay.
Yes.
Sorry, at this point, I think my battery is low. That's why it went off. Let's stop here for today. There's something I will give I will tell you one or two things in the WhatsApp group. I'll send you some message, but it seems I'll make some adjustment on this title because of other lectures. Because the light is actually dealing with us here. Before you do one lecture, the system will go off. So I'll give that directive on what we are going to do about this timetable adjustments, so that this will not be happening. Is that clear?
Yes.
Okay.
Thank you very much for your attention. God bless you. We'll see you again next time. Just look out for in your DM. I'll send you a message later in the day. All right.
Okay. Thanks, sir.
Thank you.
Thank you.
Next, I gave an assignment to. Don't worry, I'll send the assignment to you. Okay.
Okay. Thanks. Sorry, not joining late though.
No problem.
I was a bit late.